Okay, so today we're going to be talking about word problems that have polynomial factoring involved to solve for whatever you're looking for. As always with word problems, you need to make sure that you are first translating the problem into short algebraic sentences or equations is another way to think about that. And then combining those equations to create a polynomial. So at least that's the specific case that we're dealing with today. So let's look at some examples. Here's the first word problem. A wall of a tent is shaped like a triangle and has an area of 48 feet squared. The base of the wall is 2 feet shorter and 3 times the height. Find the length of the base and the height of the wall. Well, rather than reading the word problem all at once and then trying to make sense of it, it's a lot better to take each sentence and try to turn it into some fact. So they start off saying, the wall of a tent is shaped like a triangle. So here I go, I draw a triangle. It has an area of 48 feet. So the area of the triangle, which I know equals 1/2 base times height, also equals 48 feet squared. Okay, here's my height, there's my base on my diagram. It's always helpful to draw if you can actually make a picture out of whatever they're talking about. They say that the base of the wall, so here's the equation for the base, is, that always stands for equals, it's 2 feet shorter, so that's minus 2, then 3 times the height. So 3 times the height minus 2, that's my base. And you can notice I can already plug that straight into my area formula above. Find the length of the base and the height of the wall. So they want me to solve for base equals what? And height equals what? So I need both of those. This is a two-part problem. Part 1, part 2. So the base of the triangle is already in terms of h, so we're going to solve for part 2 first actually, and then come back and solve for part 1. So part 2. Let's substitute b in for b up in the area equation. So 1/2 3 times h minus 2 in parentheses, because that's what b is, times h equals 48. And at this point, I'm going to just drop the units and we can put them back in for our answer. Usually it's good to write the units the first time through, especially if you have like a physicsy problem with velocities and times and things like that. Because there's a difference between the metric system and the standard system that will require you to use different formulas, and you don't want to get caught off guard. So here you go. We can distribute the 1/2 into everything, and then we'll distribute the h into everything from over here in the second step. So 3/2 h minus, well, 1/2 of 2 is just 1, and that whole thing is times h equals 48. On these kinds of problems, you'll find that we're going to use a technique called completing the square. And that's probably what we're going to be doing here. You could try to factor it some other way, but I would prefer using completing the square. And you'll see why in a second. So, multiplying h into everything, we've got 3/2 h minus an h, that's h squared, minus h, equals 48. Okay. Completing the square means that we're going to turn this into a perfect square and then add whatever we added to make that happen to the left side and to the right side. So we're going to add something here and there to make this all a perfect square. My first problem is this right there. My second problem is this right there. This is not really a problem, but I do need to initially divide everything out by 3/2. Well, when we divide by a fraction, we're going to multiply times the reciprocal. So if I multiply 2/3 times the left side and then 2/3 times the right side, I have done the equivalent of dividing out by 3/2. So doing that, we've got h squared minus 2/3 h equals 48 divided by 3 times 2. Oh my goodness. That should be 32. We know that 48 is divisible by 3 instantly because we can add 4 and 8 to get 12, which is divisible by 3, which is your trick to figuring out if a number is divisible by 3. But you guys have got your calculator, so you don't really need that trick. The trick is just to add the digits together, and if the sum of the digits is divisible by 3, the original number was divisible by 3. So here we had 4 plus 8, that equals 12. 12 is divisible by 3, so 48 is also divisible by 3. Okay? Well, now we're on to the point of completing the square. Basically, the process looks like, can I take this part and add something to make it into a really nice, that's 2/3 8, sorry. A really nice polynomial like that factors into something. You can see h minus some number, whole thing squared, equaling whatever else is on the other side. And what's on the other side is some number squared, and then plus some number squared, and so this equals 32 plus some number squared. If you're a little confused right now, what I'm saying is that there's nice polynomials like x squared plus 2xy plus y squared, which factor into perfect squares like x plus y squared, which is this one. The instance we have has a minus sign and then a plus sign, so the whole thing factors nicely into x. It's this instance, x squared minus 2xy plus y squared, and that's x minus y, whole thing squared. All right, so that's the instance that we have here. Well, if this is the case, you can see that the negative 2, or the 2xy has to equal the 2/3 h here. And in this place, h does equal x. So what I'm saying is if I set 2xy to equal the 2/3 h, oh, but h equals x, so I should have drawn an h right here. Then I can solve for the y that I need to put here to make it look like this, that I can factor right here so that I can eventually take the square root of that and just have one h to solve for instead of h's all over the place like I have over here. So divide both sides by h, that gets rid of the h there, and then divide both sides by 2. That's the same as multiplying times 1/2 because we're dividing by a fraction, 2 over 1. So we can multiply times 1 over 2, and that gives us 1/3. So y equals 1/3. We can put that right here. We can square it up here, but I'm just going to write it as 1/3 right here. 1/3 right here, and then on this next step I'll square it. So 1 squared is 1, 3 squared is 9, so right there I have 1/9. At this stage, solving the rest of the problem is relatively easy. I need to just take the square root of this side and the square root of that side to give us h minus 1/3 over here, because that's what square roots do. They get rid of the square, and so we no longer have that thing. And then I've got this funky number, 32 plus 1/9, whole thing, take the square root of that. That's something around between 5 and 6, because I know the square root of 25 is 5, and the square root of 36 is 6. And this is a lot closer to the square root of 36 than the square root of 25. So I'm thinking it's roughly 6, especially when we solve for h, and we have